Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question. And hopefully we'll be able to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our two lucky winners. All right, we'll go ahead and kick off today's webinar, which is DevOps patterns and anti-patterns for continuous software updates. Our speaker today is none other than Baruch Sadogurski from JFrog. Baruch, thank you so much for joining me today.
Oh, thank you for having me.
Awesome. Well, I know you have a great presentation, so I'm going to put myself on mute, take myself off camera, and let you get right to it.
All right. Thank you very much, Charlene, and welcome everybody. So, as Charlene mentioned, today we're going to speak about DevOps patterns and anti-patterns for continuous software updates. And let's get to it. We have a lot of ground to cover. So before we go into how we even do software updates, let's start with the question why we need or want or have software updates at all. Obviously, some software doesn't require any updates. Here is an example. BC is a terminal calculator, and it was updated last 20 years ago, which is not really surprising because the terminal didn't change in 20 years and the rules of math didn't change in 20 years. So why would anyone bother updating it at all? If anything, I would be surprised that it was updated almost every year for a couple of years, and that's kind of, you wonder what is there for them to update at all. But obviously most of the software is different because most of the software is driven by other forces. Here's one of them, users, and they want features. And obviously they want those features as soon as possible. They want those features now, and it's up to us, the software vendors, to provide features for the users. And the way we do it is giving them software updates. Here's an example of how our world changed in the latest years in this regard. If you are old enough to remember your first mobile phone back in the 90s, it wasn't there weren't any capabilities of software update on this phone. If you wanted to update your device, at best you would go to a phone repair and they would do it for you. At worst, if you want a snake on your Nokia and you don't have a snake on your Nokia, you just buy a new phone. And another option was using what was called a data cable, but also even with this data cable, you couldn't really update anything. You can just maybe download your contact book in order to migrate it when you bought a new phone. And obviously everything changed with the smartphone, with the iPhone in 2007, I think. And obviously this is where the era of software updates for at least mobile phones started. And today most of them actually do it over there automatically without you even acknowledging this process. And that's because you want your updates, because you want your features, because you want them faster, because you want them now, and this is what the vendors do. Another good reason for software updates is security. Well, after what happened with the price of oil yesterday, I don't know if that's a good analogy anymore, but as we used to say now, the software is the new oil, and as every company becomes a software company, security vulnerabilities are the new oil spills. Security vulnerabilities are the danger of the world those days, and it is a big deal. It is fixed by different measures. And you can think about security vulnerabilities as you used to think about stopping distances when you did your driver license test. Back then, you probably were explained that there are two different parts to the stopping distance, the thinking distance and the braking distance, and they're very different in nature. The stopping distance, the thinking distance is about, light getting to your eye retina, and then signals go to brain, and then brain signals the legs, and it's all like about biochemistry and electricity pulses going inside your body. And braking distance is physics and chemistry. It's the alloy of it's the pads that friction with the wheels, and the wheels that friction with the road, and all this stuff. And those are completely different types of processes, and they are improved by completely different types of improvements. So for example, for braking distance, you come up with better alloys for the braking pads and better rubber for the tires and better surface for the roads. And for thinking distance, what you can do, you can replace slow thinking, slow reacting people with fast thinking and fast reacting machines. So you fix them completely differently. The same with security vulnerabilities. You have three different parts. The first is how you identify a problem. The second is how you fix the problem. And the third is how you deploy the fix to production, how you update your software. And a couple of examples of how different those processes are. This is from 3 years ago. The UK hospital system was completely shut down because of a ransomware worm, and obviously they figured it out immediately. And the fix was not using Windows XP, which was not supported for more than 5 years by then and didn't get security updates. So the fix was updating an operating system. An operating system is your dependency. It's your system level dependency, but still. So updating your dependency would fix this problem. And then the deployment of this took years for the UK hospital system. And this is why they have, this is how they have this problem. Another example is the Equifax breach that we had. It's also like 3 years from now, the time flies. It's a little bit similar, but in this case, it took 2 months for Equifax to actually discover that they have been breached. And then the problem was again dependency. This time it was code level dependency. It was the framework that they used, and it took them 2 months to actually deploy the fix after they were already aware that they're under attack. And obviously those 2 months didn't contribute to their security posture. In those 2 months, if they had updated faster, then probably less damage they would suffer. You might think that, okay, those are extreme examples, they're not going to happen to me, but the problem is some security vulnerabilities are impossible to defeat. And Spectre is one of those examples. That this is what we discovered in the beginning of last year, Meltdown and Spectre. It was a lot of highlight on Meltdown because how easy the exploit was, but actually Spectre is much more difficult because Spectre is impossible to defeat. There is an explanation of why in this article, and this article is available for you in the show notes that I'm going to mention in a second. So basically, you understand that all three parts of it the identify, the fix, and the update are are critical for security of your application. And while in this webinar we are not going to talk about how identify a security breach or how fix the security breach, we are definitely going to talk about how you take the software that you fixed, either your code or your dependency, and deploy to production as fast as possible by doing continuous update. So the good news are we are in a relatively good shape, surprisingly. This is the state of DevOps report from last year. We hope to see the new report soon, but this is the latest we have. And if you look at this report, and that's the most important scientific research of the DevOps industry, you can see here that they surveyed more than 31,000 organizations, and out of those 35,000 organizations, when they're broken into cohorts, you can see that 20%, every fifth organization is what they called the elite performance. And how the elite performance differs from others, one of the metrics is the deployment frequency, and the elite performance can actually deploy multiple deploys per day, as much as they need. And this obviously means that they bring value to their customers faster than others, and they can patch those security vulnerabilities with updates faster than the attacker and faster than their competitors. So obviously the elite is the place to be, and the good news is that every fifth is already there, so we have some examples to look at. This is not a new idea. The idea of update faster has been with us for many years. Extreme Programming 1998, that's 22 years ago, advocated for short feedback. Scrum 2020 years ago, advocated for reducing cycle time to absolute minimum, and it's going the same idea from there. Toyota Production System, deliver as fast as possible, Kanban, incremental change, etc., etc. So the question is, why still 80% of the industry is not there yet? As already mentioned, my name is Baruch Sadogurski. I'm Chief Sticker Officer at JFrog. In those daring times when I cannot travel and give you stickers, I also advocate for DevOps at JFrog. And the most important piece of this slide is my Twitter handle, @jbaruch. Obviously, feel free to connect with me at any time. If you are still not convinced that I'm worth your following, hopefully I will change your mind during the presentation, and conveniently my Twitter handle is on the bottom of every slide. Now, if you find this intro a little bit too aggressive, that's because on a scale of emotionally expressive and confrontational, the most emotionally expressive and confrontational people are from Israel and Russia, and I managed to be from both, which explains a lot. So I apologize in advance if I offend any of you during this presentation, and hopefully you will give me this benefit of the doubt now, knowing this little cultural anecdote, which comes to you from an amazing book called The Culture Map by Erwin Meyer, which you can find, the link to which you can find in the show notes. This is the most important slide of today's presentation. If you need to write something down, that would be this URL, jeffrog.com/show notes. You go there to find the slides, which are already there, the video that I will upload after this webinar finished, all the links, including to all the security incidents that I mentioned in the beginning, including to the explanation why Spectre might be impossible to defeat, and the culture map of Irene Meyer, the amazing book, the place to comment, to rate, and a very nice raffle of Nintendo Switches that I would like to give to you to thank you for being here in this webinar. And that's on top of the raffle that DevOps.com is going to have as well. So you just come here and boom, you win prizes, a lot, and good ones. The good news about the show notes is that you don't need to remember this URL as well, because it's also on the bottom of every slide. Okay, so let's get to it. I hope I convinced you that updating faster is a good thing, and now let's see how it actually works for people. My favorite example of updating faster will be the Java language and the JDK. So 3 years ago, almost 3 years ago, Mark Reynolds, who is, I think, like the chief architect of the Java platform, announced that they want to move faster with Java updates. Probably they heard this talk or similar, or they're smart people and figured it out by themselves that they actually need to update faster, and they decided to do it. As I mentioned, 2017. The version that was deployed, that was the latest release then, was Java 8. Since then, they released Java 9, Java 10, Java 11, Java 12, Java 13, and Java 14, 6 versions of Java. And I would expect, and you would expect by now, that the industry is excited about Java moving forward faster, excited about the opportunity to get new features faster, and ecstatically updates every time to a new version of Java. Well, that's not exactly the case. If we look at the state of developer ecosystem, that's a little bit also like last year. We don't have this year yet, but you can see that even, but at least last year, you can see that 83% of the industry are still on Java 8. We will see this year. I don't expect this number to fall drastically. Maybe it will go around 80% or maybe 75%, but still the vast majority of the industry didn't move after the announcement and after 6 new versions in production. And you wonder why? Because I think I made a pretty clear and convincing argument for getting updates faster, but it doesn't happen. To understand why it doesn't happen, we need to think about how we update software. And here's a little flow diagram for you. So let's say the update is available. We need to decide if we want it. If we don't want it, there are no nice features, there is nothing that we want, so we just won't update, like, no. But if they are, the next question will be, are they high risks? Sometimes you have software which doesn't have a high risk. Let's say it's a streaming app in your phone for streaming video, and you update it without thinking twice. Worst case scenario, if Netflix update didn't go well and something doesn't work, you will just switch to one of their competitors to watch the video for the next day, and then once Netflix fixes it, and they are for sure this elite, so they can patch multiple times a day, so the fix is coming shortly, and then you can switch back to Netflix and actually enjoy your movies back. Now, if there are high risks, the next question you ask yourself, do we trust the update? Sometimes there are high risks, but the software comes from the vendor that you blindly trust. And the example that I use here, which is should be familiar to a lot of you, is Apple and Mac OS. I would say like 4 years ago, when even if you have this pop-up of, well, you have your Mac OS update, you would safely go and update it, even though it is critical for you, it's your working machine, but you trust the provider to actually provide you update that won't break your system. Unfortunately, that's not the case anymore, and a lot of people now defer the update of their macOS operating system by many months to wait until it stabilizes, and that's exactly what it means not to trust your vendor. So, but let's say you do trust your vendor and then you update, but as I mentioned, most of the time you don't, and the question is, why? Why don't you trust your software vendor? First answer will be, well, it might be a quality issue, but I just gave you an example of a vendor that we used to trust and don't trust anymore. Does it mean that they kind of forgot how to do QA? They used to do good QA and now suddenly they forgot everything that they do? This is unlikely. Probably there are other reasons. And one of those reasons is actually complexity. We in JFrog do software for universal artifact management, and we are so deep in this artifact management domain that we measure everything in artifacts, including the complexity. And we can I can demonstrate you how the complexity risen from let's say 2000 to today by using number of artifacts as a symptom. So when continuous integration was invented, we understood that we actually need to build more frequently, and then with continuous delivery, every artifact is a candidate to be released to production, so we need to keep those artifacts around. Infrastructure is code, now hardware is software as well, and all the complexity of software now applies on hardware. Microservices obviously risen the complexity dramatically because the relationship between software now got much more complicated. Obviously with Docker, when we have those isolated containers that we hope that we know what's going on inside, but not always. And now serverless, when actually we have every 10 lines of JavaScript code is a microservice of its own running on serverless platform, and we need to take care of all the aspects of software for each and every one of them. And then obviously with IoT, the complexity goes through the roof because now the relationship are just endless. Every light bulb runs a Kubernetes cluster. Good luck with that. Another interesting symptom will be the data. And this is a survey or prediction, if you wish, by Seagate. They make storage, so they are a little bit of the interesting party, but still, if you look at the numbers, they are astonishing. So for your reference, we refer to big data today as petabytes. Petabytes are big data, but after petabytes, we have exabytes. That's 2024 petabytes. And after that, there is zettabyte. Zettabytes are 1024 exabytes, which is really, really, really a lot of data. And that actually means that it's almost impossible, and when possible, doesn't make sense to replicate production systems in staging, and this making sure that we actually test everything. It's just not economically feasible, which means that obviously the guarantees that we can provide with quality before we release anything are now weakened just because we cannot possibly test everything. So now when we understand why we don't trust, the next question is, okay, can we verify the update? We don't trust it, but we want to verify. Now, sometimes we just can't. For example, with Java, if testing our entire production system with new version of Java takes more than half a year, and there is new version of Java every half a year, probably some versions we won't even bother. We will just skip it just because there is not enough time to verify this update before new update is out. Sometimes we decide that we want to verify it because probably the features are too good to skip, but then we start the time-consuming verification. And I just gave you a clue, speaking about the features that are too good to speak. That brings the vendors to the decision of putting enough food on the table for the users to take the update. And this is the opposite of what we want to achieve with small and frequent updates, because now the trade-off is features that we really want versus acceptance test cost, and this generates an incentive to gather updates together to provide more and more features in a single update. But as more features we put in this single update, the harder it will be to verify, so the acceptance test cost risen. And this is a spiral that we don't see an easy way out, and let's see if we can do something about it. So here's a way to get out of this spiral. Update is available. Do we want it? It doesn't really matter because we will get it anyway. We will get it through auto update. And it actually works for a lot of software which doesn't have a lot of risks. For example, most of you have no idea what version of browser are they using because it's low risk. Worst case scenario, you will have to use the alternative browser for a day, but it's also auto updating. It pushes you features that you don't really know, but it's just getting updated over the time. Another example of this auto update is any web service or website that you are using. You never know what the version is, and you just go there next time and boom, there is new UI. You complain a little bit about it on Twitter, but you move on because no one asks you. But again, that's a low reason. That's a low risk. Worst case scenario, Twitter is down for an hour, so you do something useful with your life for this hour. Another example is most of the apps on your smartphone. They're all set by default to auto update, and you just get the auto update without even asking you. But when it comes to real critical pieces of software dependencies in which you do have high risks, for example, the operating system on your smartphone, that's another topic. Here you have been asked if you want to upgrade, and you will probably answer no for a couple of times just because it's high risk and you don't trust the vendor. Remember that. So let's see how we can break this and bring the trust back. So what can possibly go wrong? Why we don't trust those vendors and how can fix it? I want to start with a personal story. I own this Google router, wireless router, Google on Hub for about many years now, and it's a great piece of software. And one of the reasons why I bought it because it actually promised auto updates. And that self-improving system means exactly that. I will get over-the-air updates, my router will get smarter. That sounds like a good idea, and it's actually a very, very good piece of hardware. 3 years ago, I was on a trip in some conference, and my wife calls me and said, Baruch, the kids are sitting in the dark. And I'm like, what happened? Is the electricity down? And she's like, no, the internet is down. And they shout, Alexa, turn on the light, Alexa, turn on the light, and actually nothing happens. So this day they learned about the physical switches on the wall, and we went to debug what happened to our internet. Our provider was fine, restarting the router didn't help, and then I get this email that basically said, you know what, sorry about that, we pushed an update that reset your system to factory settings. Now what? They cannot send an update that will fix it. They cannot send an update that will roll it back. The router is unreachable, and they have nothing else to do sending me the email and asking me to fix this problem. Now, the problem is that to get an email, you have to have internet, but as I mentioned, I was on a business trip, so I was connected on a conference Wi-Fi or hotel Wi-Fi, and we actually managed to fix it. But there is a lesson here to learn, and the lesson is sometimes update goes so wrong that over-the-air patch cannot reach the device. The router is a small problem because there are people that can fix it with immediate access, but think about a solar farm somewhere in sub-Sahara or in Sahara Desert. It's a great location for a solar farm. There are a lot of sun, but to get there, you need to fly the helicopters for 3 days and then ride camels for 3 days. And obviously, if an update of the software of the solar farm goes wrong, then you have 6 days of production loss. That obviously is a lot of money. And the solution is local rollback. You have a version that is saved on the device, and then you actually can roll back to it whenever you need, and whenever something goes wrong, and this is a good idea. Now, the thing is, it's not a good idea. Since I think Windows 95 or at least 98, we had this option in our operating system. We were doing it every time we changed our monitor or our video card and change the resolution, we have this pop-up that is a local rollback. It wants us to confirm that the settings are good. And if we don't see this screen because something went catastrophically wrong with the update, we change the resolution, and now we cannot access the device because the screen is black, it will revert automatically to previous changes, and this is a local rollback. Now, we used to do it 25 years ago. Why we stopped doing it, no one knows. Now, this example of, you can say, of IoT and, routers and stuff, how it's relevant for like the normal software that we do. Well, I would say that Internet of Things, that the things in the internet stands for everything. And it's not only the small edge devices, but also your server side or even your own data center machines. They are all things in this Internet of Things. And I love the hardware and the edge and the devices updates because they drive the point home very, very clearly. And another example of such are cars. Let's talk about updating the cars. Here you go. Jaguar I-Pace, a great electric car, was released last year. Half a year after the release, they discovered they have a software issue with the brakes, which is pretty important, right? The brakes, but they didn't have any auto update, any over-the-air update, so they had to actually physically recall the cars to the service center. And the problem with that, first of all, it's costly. It costs a lot of money to recall the cars, but also you cannot force it. And probably to fix the brakes, you want to force this update, but you really can't. What you can do is send them the recall notice in a red envelope written with caps. That's the worst case you can do. Obviously, over-the-air updates solve this problem because, first of all, it's cheap, and also you can push the update to the car whenever you decide it is important. And over-the-air updates are great, but continuous over-the-air updates are even better. To demonstrate that, I will give you an example of another updating car, and that will be Tesla. And Tesla is amazing in many ways, including the over-the-air updates, but it has some glitches with their autopilot. Those are early days, and one of the annoying features called the phantom braking. The phantom braking is your car drives, and then out of the blue it slams the brakes. There is nothing in the surrounding that will require this brake, but it happens. Obviously, it's a bug, and we hope that it got fixed, and there is a rumor that it will be fixed in the next update, and then we wait and we wait, and the update that doesn't come. And the reason it doesn't come, because it was delayed to release the chess. Now, chess is important. You want to play chess when your card is charging, but is it really a good enough reason to delay the release of this bug fix that fixes the phantom braking because of the chess? Well, depends on who you are and what are your consumption practices. If you are not a chess player, but you do use autopilot, obviously this just sounds outrageous because you want the Tesla to fix the phantom braking and you don't really care about chess. But it might be the other way around. You might be a chess player that is smart. Chess players are smart, so they don't use the autopilot. So they don't care about the fix for phantom braking, but they definitely want the chess to be available. So it doesn't matter how you defined what's important for you. The problem with bulk updates is that important features wait for non-important features, and you cannot actually determine between the two because for different people, different things are important or not important. The only way to release important features without waiting for unimportant ones is to do just that, to implement continuous updates and release features as soon as they become available. And if the chess is available before the phantom breaking fix, just release the chess for people who wait for chess and don't care for the phantom breaking. And if the phantom breaking is available before chess, do just that, and people who use the autopilot, don't care about chess, will get their updates sooner. So that's important. That's small and continuous updates for you. And you might think, okay, that was enough. Continuous self-driving cars and modems. I don't do any of those. I do a web service. How it is important for me? Well, your life is much easier than of those guys because you control the availability of the target, you control the state of the target, you control the version of the target, and you control the access of the target. You actually have a lot of more. Your life is much easier, but still, even we as server-side developers who update servers either on in our data centers or in the cloud or even serverless, we actually manage to fail not less dramatically, but sometimes more. And here is a classic example that many of you might probably heard. That's a Night Capital story. And that was a very long time ago. That was 8 years ago, but still it is so impressive that definitely worth mentioning. So Night Capital was a trader company on Wall Street, huge one, fourth back then, controlling $400 million in assets, and they decided to update their software. After many, many years, they didn't do it. Actually, they decided that new system will reuse some old APIs, but do completely different things, like sell instead of buy or something like that. And then they updated 7 servers out of 8 and forgot to update the 8th one. And then new clients send requests to the machine containing old code. And as I mentioned, since they reused the same API, it did something completely different and they started to bleed money. Once they noticed this, they actually shut down the updated servers. So now 100% of the traffic went to the old server and did the wrong thing. And they didn't have any way to understand what's going on. And they actually spent 40 minutes trying to debug this thing. They lost $400 million and actually went out of business because of that. This is horrible, and there are a lot of lessons to learn from Night Capital. First of all is don't update by hand, because people are not very good in repetitive tasks. Machines are just better. So once you automate your updates and the machines are doing the updates, there is no chance that the machine will forget to update one of your servers. Another lesson is frequent updates. They didn't update for many years, so probably the people who knew how to update those systems weren't even there anymore. And it's also a very big dramatic event. It's a first update in many years, which obviously generates a lot of stress, a lot of anxiety, and they don't have the skill to do it. So instead, if you update frequently, you develop a skill and habit. So even if you as an organization feel that you don't need to release features very frequently because this is the reality of your industry, still it's worth maintaining this update skill and update frequently, even with small stuff, or even, you know what, just dry runs of the updates. So when you need to do it in real time, you will have the needed skills to do it. Obviously, state awareness. They reused old state. Probably they had the reasons, but obviously they didn't think about the implications of something like this happening. And more so, when you reuse the existing state and your clients are getting updated, you need to remember that you might have to revert and then have this scenario to think about as well, especially when it comes to reverting the state, what it will do when the new clients call old APIs. So a lot of lessons. Another very, I would say, remarkable failure was last year with Cloudflare, when the internet, almost all the internet, like tons of sites went down for 30 minutes, and that's because Cloudflare actually had 30 minutes of downtime because of what happened. So what happened? Cloudflare deploys new rules to battle internet attacks, and one of the rules was misconfigured, which, by the way, makes me thinking that probably the end of our civilization won't come from the current pandemic of COVID virus, or the meteorite, or global warming, or nuclear war, but actually as a result of one misconfigured regular expression. That's exactly what happened in Cloudflare. This rule had a regular expression which caused the CPU to spike 100%, and then obviously the failover servers kicks in, also got the misconfigured rules, spiked their CPU to 100%, and at the end of the day, the Cloudflare status page actually mentioned affected region Earth, which was true, and obviously there are some lessons to learn from that as well. And the first one, like the big one, is progressive delivery. And progressive delivery is a concept that with us for a couple of years now, and it actually goes like, do not release something that might contain a bug to all the users. Instead, release to a small number of users first, effectively reducing the blast radius, and then observe what happens. And if the problem occurs, you stop the release, you revert the affected users or update them with a patch if it's available, and basically minimize the harm that is done by a bad update. And again, this is something that you would expect all of us to get, because this concept is with us since we were young kids. When our parents taught us how to do laundry, we probably saw this warning on every fabric treatment material: always spot test on a hidden service first. Always spot test on the hidden service first is progressive delivery. We try in some small area, and if it's great, we treat the entire fabric, and if it's bad, then we don't. So that's exactly the concept. And again, we failed to take this simple concept that with us today and migrate it to software. And that's a shame, because a lot of things in life do prepare us to provide better software, and we not always see the analogies. So observability, when you have, especially when you have progressive delivery, you want to know about them at once, and not when people start complaining on Twitter, and then tracing, monitoring, logging, and action of all those. This is how you actually go about what to do with your progressive delivery. So if you see that you release something in canary release, and then your system performance degrades, your CPU spikes for 100%, automatically your system that has the observability implemented should roll back, stop the release, roll back, and actually go to previous system. And rollback is the idea that instead of waiting for the next update that will fix the problem, we can actually go to a previous version to release the problem to fix the problem while we are working on the fix. And the problem with rollbacks is that you need to have an infrastructure that supports it. And for example, the mobile platforms, both the Google Play Store and the Apple App Store, do not support rollbacks. If you release the version and now you want to go back to a previous version, there is no way to do it. Instead, you need to take the previous version, rename it as the next version, submit it to those platforms to review, wait for manual review, and only then you can actually implement it. And obviously it will take days, but in those days your users will suffer from a problem. So then what you can do is you can use feature flags. You can embed kind of two features of the same app inside your app, and then switch it with an API. So for example, if you have functionality that doesn't work as expected, you can turn it off by using feature flag while it will be fixed. And my favorite example, one of the most important ones, is the Movie Pass. Movie Pass is a cinema subscription system that you pay once every month, and then you can go to as many movies as you like. And that sounds like a good idea. And those folks weren't to update their software for at least 5 weeks. And the problem is that when they come back from those 5 weeks of updating the software, they will probably find that they have no users anymore. And that's exactly what happened. After this 5 weeks update of their mobile app, they came back just to declare they're going out of business because users didn't wait for 5 weeks for them to restore their app. Instead, you want to perform zero downtime over there, small and frequent continuous updates. So to summarize, continuous updates are frequent, automatic, tested, progressively delivered, state-aware, observable, and implement local rollbacks. That's kind of an extra creative task. It's complicated, not always needed, but if you do everything else, then you are in good shape. And then we go to this diagram again, because now we do have auto update for low risk applications, but also for high risk applications, because if we build this trust using continuous updates between the vendor and the customer, then there is no problem to get a new version every time it is available without being worried of what's going to happen and how it will behave. And our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates, so tiny and so frequent that they will provide an illusion of software flowing from development to the update target. And this is what we call the liquid software vision. It looks like the software flows like liquid from the vendor to the customer. And to explain this vision, we wrote a book. Two co-founders of JFrog, Fred Simon and Yoav Landman, and yours truly, we all co-authored a book that's called The Liquid Software, that explains how to achieve continuous updates in the DevOps world. And you can learn more about this book at liquidsoftware.com, and there is a hashtag Liquid Software right here in the bottom of our slide as well. The last thing before we get to the questions is the topic of corner cases. You probably think by now, well, yeah, it's nice for some kind of software, but I don't believe that any kind of software should be updated continuously. And you will be surprised how, at least in our view, small the number of those exceptions. How about updating planes mid-flight? Sounds like a crazy idea. I bet the majority of you think that this is a proper exception when we don't want the continuous updates. And what I want to do in 2 minutes before we get to Q&A is try to change your mind. So there is a thing in the aerospace industry. Their software skills of the software engineers are the same as everywhere else. Which brings us to bugs. Airbus A350 has a memory leak. It has to be restarted every 149 hours. Boeing 747 has the registers overflow, and it has to be restarted every 51 days. There are bugs in planes. Some of those bugs might be critical. So for example, you fly mid-Pacific, well, we can only imagine that we fly, but let's say it, from Los Angeles to Tokyo, and we forgot to restart our plane. Now what? Wouldn't it be nice to actually push a fix and solve this memory leak mid-flight? Wouldn't it save all the people on the flight? It will. So here's an example when continuous updates implemented for even the planes can actually save lives and being important. And not that updates of the plane mid-flight is something unheard of. Here's an example from Boeing 777 that was the first Boeing that was completely driven by software, kind of the Tesla for cars now, when it's just a machine on the wheels. So 777 was a computer on wheels. So 777 was computer with wings, and they have the bug that they couldn't fix on the ground with offsetting turbulence. So they took all the developers, put them on the plane, took off, flew to the area of high turbulence, debugged the problem mid-air, updated the problem, updated the software mid-air, and actually saved, and fixed the bug. So now we have 10 minutes for your questions. And just to remind you, I'm at jbaruch on Twitter. Liquid Software is the hashtag for the Liquid Software. Liquidsoftware.com is the website to visit, and jeffrey.com/show notes is the show notes page that you find all the information in it. This QR code will take you to the show notes page as well. So with that, let's get to your questions.
Yeah, we do have a couple questions that have come in. So let's go ahead and start with this one. Okay, this is back to your Java conversation. Is it only trust issue for the developer to not switch over to Java 14, or are there also some performance issues? This is because 83% of developers using the 8th version is actually a huge number.
Yes, so well, I would say that performance issues are not different from any other bugs or issues. And if I think that my software will have degraded performance after an update, and this is why I am update avert now, it's the same. It's the issue of trust. I don't trust my vendor to make sure that the performance will only improve instead of decrease. So that's exactly back. I don't trust my software. Now, in the defense of Java, I hope the example played well in the talk, but I actually cheated a little bit. Obviously, the major version updates that break backwards compatibility and promise changes that are not compatible with previous versions will generate acceptance testing and processes of adapting the software as it was a new version. So I'm not being fair saying that Java did something wrong because people won't accept it. Those every half a year they have a new major version, which in my book, and that's funny, it's literally in my book, in Liquid Software, we actually speak about how major updates are as you adapt a completely new application, so the rules of updates do not apply for major versions. So although I love to use this example to show how people are update avert, it's not really fair because for Java versions are new applications. But I hope you got my gist. People still refrain from updating even for minor versions, and this is for sure the lack of trust.
All right. Okay, great. Next question here. Are there any books you recommend on how to manage software updating and packaging?
It looks like I actually planned this question, but I didn't.
No,
so thank you for asking. Yes, there is a book talking about how to go about continuous updates. It's called the Liquid Software, and this is how to implement continuous updates. Yeah, so I guess this question was before I mentioned the book, so here you go. Yeah.
Okay, great. All right, so next question. How do we communicate to the customers using our application also update as soon as possible?
Well, yeah, so our belief is that customers want to update as soon as possible. And that's because this is how they get new features. This is how they are better protected security-wise, right? This is how they get all the security updates. And you don't need to convince anyone. The only thing that you need to know, that you need to do, is to establish this trust. Once you have this trust in place, they will take your updates without you doing any type of convincing. The only reason why they don't take your updates now is because they don't trust your update.
All right. I think we have time for one more question here. In the modern web apps, which cheaply relies on the JS frameworks, which evolves much faster than Java, what could be the strategies to be followed?
Well, it's exactly the same. I mean, nothing changes here. You as a developer for your mobile app that depends on some other framework, you need to ask yourself, do you trust this vendor of your framework. If you do, you can improve your apps by getting updates from your dependencies much faster, and then actually this trust delegates to your users, and they will take your apps if they trust you, which transitively means they trust the frameworks. Now, obviously, unfortunately, today that's not the case. Both you don't trust your new and shiny JavaScript frameworks that come out every half a year, and your customers won't trust you because of that. Your code might be flawless, but if your framework has a lot of bugs and security vulnerabilities, obviously this delegates to the end quality of your product. So I think it's a chain that goes all the way, and this brings us to the importance of the trust between the infrastructure providers or the dependency providers and you. And the software providers that depend on others are in an impossible situation of, we want to build this trust with our customer, but we don't have the trust with our software providers, the vendors of our dependencies. And the only two solutions for that is to apply pressure for continuous updates backwards to the vendors that you don't trust, and make sure that you trust them now. And the other is just being very, very careful with your dependencies, unfortunately, until this trust can be gained.
All right. All right. Well, we're about 4 minutes to the top of the hour, so unfortunately we do have to close out the question and answer period, but I do want to thank everybody who did submit questions. If for some reason we didn't get to your question, please know that Baruch and the folks at JFrog will be getting a copy of all of the questions, so I'm sure they'll be more than happy to follow up with you. Also, want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Baruch mentioned that it's going to be living on the JFrog website. But in addition, we will be sending out an email that contains a link to access the webinar on demand. And we are going to have it living on the DevOps.com website. You can always just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Also, before we close things out, I know at the top of the hour I mentioned a drawing for 2 $50 Amazon gift cards. So without further ado, let's go ahead and get to that. Our first winner today is Ben R. Congratulations, Ben. And our second winner today is John B. Congratulations, John B. and Ben R. We will be following up with you guys via email to get your $50 Amazon gift card over to you. Baruch, thank you as always for such a great presentation. Good stuff.
Thank you.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon and I'm signing off. Have a great day, everybody. Stay safe.
Thank you. Bye-bye.